In this video, we are going to look at the properties and reactions of group 2 metals that you need to know for Edexcel A-level chemistry. This is a revision video. For more detailed explanations about the content covered, please check the links in the description below. Atomic radius of the group 2 metals increases down the group. The atoms get larger. The first ionization energy of the group 2 metals decreases down the group. This tells us that it gets easier to remove an electron from an atom of each metal as you go down the group. Reactivity of the group 2 metals increases down the group, meaning they more readily form ions with a 2+ charge. They form ions with a 2+ charge as they lose their 2 outermost electrons from a full s subshell. This trend in reactivity can be seen by looking at the reactions of the group 2 metals with water. When a group 2 metal reacts with water, a metal hydroxide and hydrogen gas gets formed. The general reaction is metal M plus 2H2O forms MOH2 plus H2. Magnesium reacts very slowly with cold water to form magnesium hydroxide. The reaction is slow due to insoluble magnesium hydroxide forming on the surface of the magnesium. Magnesium reacts quickly with steam to form magnesium oxide, MgO. Calcium reacts steadily with cold water, strontium reacts quickly with cold water, and barium reacts rapidly with cold water. The reactions become increasingly vigorous as you go down the group, showing an increase in the reactivities of the metals. Group 2 metals react with oxygen to form group 2 metal oxides, with a general reaction of metal plus oxygen to metal oxide. 2M plus O2 forms 2MO. The reactions are vigorous when the metal is heated in oxygen. For example, magnesium burns in oxygen with a bright and white flame. Group 2 metals react with chlorine gas to form metal chlorides, with a general reaction of metal M plus Cl2 to metal chloride, MCl2. Group 2 metal oxides react with water to form metal hydroxides and an alkaline solution, with a general reaction of metal oxide plus water to metal hydroxide. MO plus H2O forms MOH2. The reactions get more vigorous as you go down the group, and the solubility of the metal hydroxides formed increases down the group, meaning the solutions become more alkaline, as more hydroxide OH- ions are present in the solution. Apart from beryllium oxide, BeO, the group 2 metal oxides are basic. Beryllium oxide is amphoteric, it can react with both acids and bases. Magnesium oxide, MgO, reacts with water to form a weakly alkaline solution with a pH of approximately 9. Calcium oxide, CaO, reacts quickly with water, producing a solution with a pH of approximately 12. Strontium oxide, SrO, and barium oxide, BaO, react vigorously with water and produce highly alkaline solutions with very high pHs. Group 2 metal hydroxides don't react with water, however do react with dilute acids to form metal salts and water, with a general reaction of metal hydroxide plus acid to salt plus water. The salt formed depends on the acid used. Methyl hydroxide plus dilute hydrochloric acid forms metal chloride, MCl2, and water. And metal hydroxide plus dilute sulfuric acid forms metal sulfate, MSO4, plus water. The salts formed are colorless in solution. However, for the reaction of barium hydroxide with dilute sulfuric acid, barium sulfate, BaSO4, gets produced. And as barium sulfate is insoluble, a white precipitate forms. Group 2 metal oxides react with dilute acids to form metal salts and water, with a general reaction of metal oxide plus acid to salt plus water. Again, the salt that gets formed depends on the dilute acid that reacts with the metal. For example, metal oxide plus dilute hydrochloric acid forms metal chloride and water. Metal oxide plus dilute sulfuric acid forms metal sulfate and water, and metal oxide plus dilute nitric acid forms metal nitrate and water. For reactions between the metal oxides and dilute hydrochloric and dilute nitric acid, the reactions get more vigorous down the group. For reactions between the metal oxides and dilute sulfuric acid, however, the reactions become less vigorous as you go down the group, and can even stop. This is because a metal sulfate gets formed, and as the solubilities of the group 2 metal sulfates decrease down the group, if an insoluble metal sulfate forms on the surface of the metal oxide, the reaction can no longer proceed as the acid is unable to get to the remaining metal oxide. The solubility of group 2 metal hydroxides increases down the group. This means the metal hydroxides more easily split apart and dissociate in solution, releasing a metal ion with a 2+ charge and hydroxide OH- ions. As a result, more soluble metal hydroxides produce solutions with a higher pH, as the higher the concentration of OH- ions in a solution, the greater its pH. This means solutions of the group 2 metal hydroxides become increasingly more alkaline, a higher pH, as you go down the group, as observed earlier with the reactions between group 2 metals and water. This means group 2 metal hydroxides can neutralize acids, which can be useful. For example, magnesium hydroxide, MgOH2, is used in medicine to help neutralize excess stomach acid and raise the pH slightly in a person's stomach. Calcium hydroxide, CaOH2, is also used in a similar way in agriculture to raise the pH of soils that are too acidic. The solubility of the group 2 metal sulfates decreases down the group. Group 2 metal sulfates are made up of a metal ion, M2+, and a sulfate ion, SO4 2-, and when they dissolve in water, they release a metal ion and a sulfate ion into solution. Magnesium sulfate, MgSO4, is highly soluble in water, whereas barium sulfate, BaSO4, is insoluble. The insoluble nature of barium sulfate enables it to be used in medicine. Being a metal, barium shows up well in an X-ray. The only problem is it's highly toxic when ingested. Because barium sulfate is insoluble, however, the barium is trapped in the sulfate compound and cannot do any damage to a patient's body. A patient can ingest barium sulfate, and when X-rayed, we can see where the barium sulfate is in the patient's body. This can help identify digestive disorders. The insoluble nature of barium sulfate also allows sulfate ions in solution to be identified by adding aqueous barium, Ba2+, ions. The barium ions combine with sulfate ions forming barium sulfate, BaSO4, which, because it is insoluble, shows as a white precipitate. The barium ions are added from a solution of acidified barium chloride, BaCl2. The solution must be acidified to ensure any carbonate ions present in the solution are removed. Otherwise, they would also combine with the barium ions, forming barium carbonate, BaCO3, also a white precipitate. Meaning, if a white precipitate formed, you wouldn't know if it is from sulfate ions or carbonate ions. The thermal stability of group 2 metal nitrates and carbonates increases down the group. It gets harder to break them down with heat. Group 2 metal nitrates, MnO3(2), break down into a metal oxide, nitrogen dioxide, and oxygen gas when heated. The starting metal nitrate and the metal oxide formed are both white solids, with the nitrogen dioxide a brown gas. Group 2 metal carbonates, MCO3, break down into a metal oxide and carbon dioxide gas when heated, MCO3 to MO plus CO2. The starting metal carbonate and the metal oxide formed are both white solids, with the carbon dioxide a colourless gas. These reactions are called thermal decomposition reactions, and they happen because the positively charged metal ions in the compounds are able to polarize the negatively charged nitrate or carbonate ion, weakening the bonds in it and enabling the ion to be split apart when heated. It gets harder to break apart the group 2 metal nitrates and carbonates as you go down the group, because the metal ions in the compounds have a larger atomic radius with the same charge, 2+. This means they polarize the negatively charged nitrate and carbonate ions less, meaning it is harder to break them apart. As a result, more heat is required for the thermal decomposition to occur.